This video has the extra 6 examples for Module 8, so that if you need some extra pieces to see, you can watch this. Again, at any time you need to, pause it. Make sure you can do it on your own. You may do it slightly different, as she does it slightly different than our videos, but our goal is so that one of these techniques will click with you. So, starting with number 1, we have a square root, and we need to make sure we are not breaking any of the rules of simplifying, having any perfect roots underneath the radical. And if we look at this, again, it's all multiplication, so we can look at them as separate pieces. 25 is a perfect square. X to the 10th is a perfect square. And y to the 20th is a perfect square. So I'm writing it this way so you can again see it as a product, but you can skip this step. Square root of 25 is 5. There are 5 pairs of x's. There are 10 pairs of y's. I would recommend, at least if you're going to just go from the very beginning one, that you circle again if they're perfect squares, because then you know that everything comes out and there's nothing left because there's nothing that's not circled. Again, it's just a way to tell your brain that everything is out, there is no radical left. So this is my answer. Going to number 2, directions would say simplify. Again, we can add like radicals. Right now, neither of them match, so we need to first simplify them. So 50 is 25 times 2, so I can pull out a 5, and I'm left with a radical 2. Out of the second radical, we have 4 times 2. So again, using the product rule, I can pull a 2 out, and that 2 is left. Yes, I did skip the step of showing that product, but you can understand that. You can show it if you need to. In this case now, we can use the distributive property, and some of you will skip showing that step as well. And we keep the radical. We add or subtract the coefficient that's in front as long as the radicals match, because we're using the distributive property. So my answer for number 2 is 3 radical 2. Going to number 3, we're using the product rule first. So I'm going to multiply, since they're both underneath the radical, of square root. 8 times 3 is 24. Remember, there's a 1 here by this exponent, so we add our exponents, so that's going to give me 3 plus 1, which gives me 4. We need to rewrite this. 24 is 4 times 6. The 4, the reason why I broke it up that way is I'm looking for a perfect square root to be able to pull out. So yes, I can rewrite 24 as 12 times 2, but that doesn't work because it's not a perfect square. Y to the 4th is a perfect square as well, because I have a perfect amount of pairs. So 2 comes out from the square root of 4. There are 2 pairs of y's. The 6 stays. Is this not a perfect square? That is my answer. Again, some of you may show some different steps in here. She shows an alternative way. So you have to use, again, what is going to click best with your brain. Going to number 4, we now have a binomial times a binomial. And again, I want you to make sure you understand that this is a difference of squares. It's really important that you recognize that. Doesn't matter if the plus or minus is first, but one has to be an addition and one has to be a subtraction. And it says take the first and square it, minus take the second and square it. Square root of x quantity squared leaves me an x. Be careful again, 7 squared is 49. That is my answer. Number 5, we need to be careful. It's really important that you do not just tell me that's 9 plus 2. That's a huge no-no. You need to understand that this means to rewrite it first, and we're going to FOIL it. So 3 times 3 is 9. 3 times radical 2 gives me 3 radical 2. My inner, same thing, 3 radical 2. My last, be careful, it's radical 2 times radical 2, so that gives me radical 4. Remember, if it's on the outside of the radical, you multiply it together. If it's on the inside of the radical, you multiply it together. These two match. So 3 plus 3, we get 6 radical 2, because remember, you keep the radical when you're adding. 4, square root of 4 is 2. Again, these two are like terms, so I end up with 11 plus 6 radical 2. I cannot add those two together because one has a radical and one does not. Please be careful and don't go further than you're supposed to. If they have like radicals, we can add them together, just like a like variable, we can add them together. So last one here is one where it would have said rationalize the denominator. In this case, I'm going to multiply by the square root of 6. Again, numerator, denominator. So this gives me 3 radical 6 on the top because the 3 is not underneath it. In the denominator, I have the square root of 36. Square root of 36 gives me a 6. This is where you now need to be careful because this 3 is on the outside and this 6 is on the outside. So I can simplify those. 3 goes into 6. It leaves me with a 2. I cannot reduce the radical 6 and a 2 because radical 6 has a radical over it. 2 does not. Please watch any of these again that you need to. Double check your work. Don't skip steps. Write down your perfect roots. It's very helpful for you to do.